Today I'm going to talk about the DynoChem process scheme tool and how its use has brought value into our process understanding and engineering assessments here at Amgen. I hope that you'll walk away from this webinar today with ideas how you can use this tool and how it can bring value to your work. I'll start by showing you what the process schemes are and show you how to build them. I'll discuss how using the process schemes can add value to your work and highlight when they should be used. And I'll share some of our workflow and approaches to engineering assessments and risk assessments to illustrate how process schemes have been integrated into these activities. I also have a few examples of where other DynoChem utilities and models have been applied. Throughout the talk, you'll see some examples of how we've modified these process scheme templates and added data to the process scheme templates to really customize them for our use. And the whole idea behind this is customize these files, make them work for your needs. Okay, so first off, what are process schemes? The process schemes are essentially a graphical representation of a process or unit operation. We like to break it down unit operation by unit operation so that we don't get too cluttered on these things. But the idea behind it is you're going to define the phases of your process, similar to how they're defined in your DynoChem models, feed tanks, bulk liquids, solids, vapors, and then define which components are in each of these phases. We also define rates, flows, reactions. Here you'll see some mechanistic steps for a reaction scheme. And we also like to capture process parameter information and data that's related and relevant to that process. Like all DynoChem tools, the process schemes are, a Microsoft Excel file. But unlike the utilities and models, you don't need to run DynoChem software in the background for these. They're a standalone Excel file. So anyone in your company can use them. Anyone can access them. They're not going to take up any of your DynoChem licenses while you're viewing them, editing them. So it's really a tool for anyone to use. And the best part is you don't even really need to know how to use DynoChem to use the process scheme tool. So I like to look at these like these files as a dashboard for process knowledge. So how do I build a process scheme? Well, for this, I'm going to take you right into the DynoChem file. You can find this if you go to DynoChem resources. Just type in process scheme in the search tab, and you'll find the file there to pull right up. All right, so I'll go ahead and drag this onto here. When you open up the process scheme tool file, you're going to see a series of tabs. The first one, where Scale-Up Systems has talked about when and how to use these. The next tab is going to be your recipe tab. And on here, you can take your ChemDraw image of the reaction and paste it in here, or if you want to just paste your step-by-step how the process is run, maybe lay out some objectives or constraints. Where the real cool stuff is here on the process scheme tab, and this is where we start to build the picture of our process. Well, for our group at Amgen, we found value in using the process scheme tool throughout the development phases of a project. In early phase development, they can be helpful. Again, when putting it together, you're taking that step back to identify important phases and rates that need to be understood in order to understand the process. We found they're useful before setting up a model. Again, it's preparing you to fill out that process tab on your DynoChem models, making sure you've identified all the components within each phase, highlighting the important rates and equilibria that really drive the process. And you'll also notice when you do go on the DynoChem resources page and you click on a model, a process scheme is going to be displayed in that little pop-up box. So if you've put together your process scheme ahead of time, you can kind of compare it to that one, make sure that you're choosing the most appropriate model template for the system you're trying to describe. We've also found that putting together a process scheme before designing a series of experiments can help you identify data that you need to collect that you maybe didn't think of beforehand. It's that visual tool, that visual aid that helps you take a different approach. And we're feeding our starting material from a feed tank at a given flow rate Q. when it enters the reactor, this is becoming the dispersed liquid phase. And you can see we've actually taken some images from process video microscope and put them right here on the process scheme tab. So we have an idea of, what are the droplet sizes, what do they look like across a range of agitation speeds. And then we've captured some of the reaction information here in the process scheme. So these are some mechanistic steps for the desired reaction as well as the undesired formation of this ether impurity. With this information laid out, they moved on to the engineering assessment phase. They posed a challenge for optimization. So they wanted to determine the relationship between surface area and number of heat cycles to make sure they had an optimized process, as these heat cycles could really increase the cycle time of the process. They identified knowledge gaps here, one of them being heat transfer impact. So we're doing heat cycles. They want to know, at larger scale, would they be able to keep this cooling profile with the increased length scales and heat transfer? And they wanted to develop design spaces. We find that it can be very useful to include references to where the data is right here in the process scheme. Another thing that we like to do is, these are Microsoft Excel files. We can hyperlink mixing utilities, whatever models and utilities we've used in DynoChem to generate this data, you can link right in here.